So this question starts off by providing us with this function. Looks like we have the product of two binomials here. The question goes on to say the function f is defined by the given equation. For what value of x does f of x reach its minimum? All right, so which value of x does f of x reach its minimum? So what do we know about this? Well, I know that if I were to graph this, I'd have x-intercepts here at 10 and at negative 13. So those would be my x-intercepts. How do I know that? It's because, well, when you have an x-intercept, your y value is 0. In order for the product of these two binomials to equal 0, one way in which that happens is x is 10, because of course 10 minus 10 becomes 0, and 0 times this is 0. Another way in which that happens is x equals negative 13. Of course, again, because if this were negative 13, this becomes 0, and 0 times 0 is 0. Okay, so that's how I know that that's where my intercepts are. This is also going to be a parabola. In fact, let me backtrack. So the digital SAT provides you with a graphing calculator. This would be a great reason to use it, and the hint really here is reaches its minimum. Minimum is a visual concept. It's a mathematical concept as well, don't get me wrong, but really, you want to see where something is at its lowest point. So whenever I see minimum or maximum for something that can be graphed, at least have that in your toolkit of options, where you can just throw it into the graphing calculator. So when you type this into your graphing calculator, you will see that your graph looks just like, let me just have it pulled up here on the side, pretty much like this. And that the x value of the minimum, the vertex here, aligns with negative 1.5. That negative 1.5 is the same as negative 3/2, so there's our answer, right? So it's kind of the best way, I think the easiest way, right? This literally takes, 10 seconds to type in. You get this visual output that you can look at really fast, and you just find where that minimum value is. So it should take less than 30 seconds to answer this question.